Okay, let's try another one. Just like keep working our way through these just so we can see lots of examples. So once again, I need to write this thing as an augmented matrix with an identity on the right-hand side. That identity on the right, I'm gonna mess up, make it real gross looking, but by the end, I should hopefully end up having my inverse there. Now we're lucky in this one. We're actually starting out with a 1 right there, so sweet, that's already done. We got to just deal with that too. Okay, well, that's easy. We'll do the opposite of that. Use the row that has a 1 in it. Add that to the row that we're messing with, and keep it right in that row. Okay, so that is going to be -2 times 1. It's -2 plus 2, that's 0. -2 times 4 is -8 plus 9. Oh my gosh, that's a 1 as well. That's so nice. Thank you, matrix. -2 times 1 is -2 plus 0. That's -2. -2 times 0, that's 0. Okay, so that's already done. So we can just move on to this thing. Okay, well, -4, row 2's, and that's row 1. That in row 1. And then we'll be done. Oh my gosh. Thank you for being nice, matrix. 0, 1, -2, 1. Okay. -4 times 0, that's 0 plus 1, that's 1. And then -4 times 1, that is -4 plus 4, that's 0. Cool. -4 times -2 is 8, plus 1 is 9. -4 times 1 is -4 plus 0 is -4. So our inverse matrix, so A inverse equals 9, -4, -2, 1. Again, this is another one that had a nice determinant, so it did kind of look like we just sort of moved some stuff around and slapped a negative on. It's not always going to be the case. It's not always going to be the case. Hopefully, we'll see that in our next one here. Nope. No, this one's going to kind of do that as well. But that's okay. We're just trying to make sure that we've got a nice rhythm for solving these. So let's do it again. Same deal. 1, 2, 3, 5. Oops. 1, 0, 0, 1. All right. So we lucked out. We got a 1 right there. Let's fix that 3 next. So we need to do -3 row 1's. Add that to row 2. And put that in row 2. So we got 1, 2, 1, 0. And then our new row 2 is, let's see, -3 times 1, that's -3. Plus 3 is 0. -3 times 2 is -6. Plus 5, ooh, -1. Oh, nice. -3 times 1 is -3 plus 0 is -3. -3 times 0 is 0 plus 1 is 1. Now we just got to do a quick switcheroo on this one. So negative row 2, put that in row 2. Nope. All right. So that is going to be 0, 1, 3, -1. So we get -2 row 2's. We're going to add that to row 1. That is our new row 1, and we should have our inverse. Nope. So -2 times 0, that's 0. Plus 1, that's -1. -2 times 1 is -2, plus 2 is 0. -2 times 3 is -6. plus 1 is -5. And -2 times -1 is 2, plus 0 is 2. So our inverse is just what's left in there. -5, 2, 3, -1. And just like when we were solving systems, you can type these into your calculator and make sure that what you're getting here is matching your calculator. So you can use the calculator to double check. Same time, same deal. We're going to go to fraction town. Ooh, I cracked my shoulder and that really hurt. Ouch. Ouch, ouch, ouch. 2, -11, 8. Oh, that's not how you write an identity. There we go. Okay, so how can I get to not fraction town? Well, actually, I could. I have an idea. I have an idea. My notes actually tell me I need to divide that first row by 2 to start off. However, if I did 6 times this row and added that to row 2, oh boy, we wouldn't have fractions right away. I know the final answer is going to have some gross fractions in it, but it's going to get there eventually anyway. But the longer I can put them off, the better. So let's try to put it off for just a minute. So if I do 6 row 1s, add that to row 2, that can be our new row 1. But then I got to get somebody in row 2, so let's take row 1 and we'll put that in row 2. Don't want to lose that old equation. Because this row's pretty nice. 2, -10, 1, 0. Then for this top one, I'm not matching my colors correctly. So 6 times 2 is 12, plus -11 is 1. Then, but now here's the consequences of that action. 6 times -10 is -60. Oof. So that's -52. Ooh. How about -54? No, 52. -52. Then we've got 6 times 1 is 6, plus 0 is 6. 6 times 0 is 0, plus 1 is 1. Okay. Next, we've got to fix this 2. So that is going to be -2 row 1s. Add that to row 2. That in row 2. So keep the top row. U52. 6, 1. So -2 times 1 is -2, plus 2 is 0. -2 times 52, jeepers. That is 104. Positive 104 minus 10, that's 94. Then -2 times row 1, that's -6. -12 plus 1 is 11. -11. And then -2 times 1 is -2 plus 0. Well, that's just a -2. So that's nice. Okay. Well, now what? Oh no. We need to divide this row by 94. Ooh, gross. Don't worry, I know what the answer is, and so it's gonna get there. And it has this gross 94 on it. Okay. Keep the top row. So my new second row, 0 divided by 94 is still 0. 94 divided by 94 is 1. And we get negative 11 94ths u. And then negative 2 divided by 94. I can actually undo, because those are two even numbers. We get negative 2 94ths. So we could divide both of those by 2. And that's going to get me, let's just keep them 94ths for now. Because we're about to like multiply this by something. And so if we just kept them both 94s, that'll make our lives a little bit easier. All right, last step. We just got to deal with that 52. So let's just get 52 row 2's. We'll add that to row 1. And then that'll be our new row 1. I do know what the answer is, and the final answer does have this negative 11/94, so I know I'm good there. The final answer also has a negative 1/47, which is the same. That's what this is. This is negative 1/47. So I know I've got the right answer in terms of the bottom row. Just don't know about that 6 and the 1 right now. Well, let's find out though. 52 times 0 is 0, plus 1 is still 1. 52 times 1 is 52, plus negative 52 is 0. Then we've got this negative 11 94ths times 52 for 1 plus 6. Gross. So this is one it's fine to just type it into your calculator. Like fractions this bad? I mean, come on. That's not the point of this. So if you type that all into your calculator, you should get negative 4/47. I'll confirm that off recording. Then we got to do 52 and then negative 2/94. 2 94 times 52 plus 1. If you type that all into your calculator, you should get negative 5/47. I'm just going to confirm that quick. Yep, that all does check out. So we get our final answer as the numbers that are written kind of sloppily. So let me in a nice place for them. A inverse equals negative 4/47, negative 5/47, negative 11/94, and negative 1/47. That is a very gross inverse. Ew, ew, ew. Oh well, sometimes they're gross. Now, all these methods can be used, in order to solve matrix equations. What you would have to do is you need to first write the matrix equation, AX equals B. Then you would need to find the inverse, which was doing all the stuff that we were just doing here. After you had done all that, you then get your inverse thing. Your answer to that system is A inverse times B. So you would then have to take the inverse answer that you just got and multiply it by your answer matrix. And it's so much work. Reduced row echelon form works so much more efficiently that it doesn't make sense to solve a matrix using an inverse matrix. Solve a matrix equation using an inverse matrix. Don't do that. It doesn't really make any sense by hand. It can make sense if you're working on a bigger equation and you're using a calculator in order to figure out what these inverses are, then that's fine. But in terms of doing it by hand, it's real dumb. It's real dumb these days. So don't bother with any of that. There may be a lesson in the future where that exists, but it's not going to happen this year. So that is it for our inverse matrix and our identity matrix. This was more just to see other things that you can do with these matrices. Thank you for watching. Have a good rest of your day. Bye-bye.